Hello learners, and welcome again to today's lesson. My name is Mr. Meshak Ngige, and welcome again to E-Maths with Ngige. So kindly subscribe, share, and also comment how these lessons are being helpful to you, as today we are going to be looking something new, and that is the expansion of cos of n theta and sine of n theta, where in this case, different from what you looked before, n is the power. All right. So now let's start by defining some few things. So we have our z. Let's say we shall let our z to be given by, z will be given by cos of theta plus j sine of theta. So I think you have already seen this. This is just the polar form of a complex number. Now in this case, we have not included our what? We have not included our r. All right. Now when we get the z, the conjugate, that is 1 over z, this function here, therefore we shall have cos of theta, then it changed the sign from a positive, it becomes negative, then j sine what? J sine theta. Now I want us to add our z and our 1 over z, our z and 1 over z, so z plus 1 over z, which will give us, so we take the right hand side also and we add, so we shall have cos of theta plus j sine of theta, right? Then we add to cos of theta minus j sine theta. So expanding the right hand side, we shall have cos of theta plus j sine of theta, right? Then opening this bracket, we shall have cos of theta, then a positive and a negative still remains to be what? It remains to be negative. Now adding and subtracting like terms, so we have cos theta and we have a cos theta here, so adding them, so these are 1 cos theta and 1 cos theta, so it becomes how many? 2 cosine of what? 2 cosine of theta. Then we have plus j sine theta minus j sine theta, so you can see here we have a positive and we have a negative, therefore this is the same as saying j sine theta minus j sine theta, which gives us what? It gives us 0. So that is the first relation. Then we can also check z minus 1 over z. So the procedure again, so we have cos of theta plus j sine of theta, right? Then we subtract cos of theta minus j sine of what? Sine of theta. Now opening the brackets, we shall have cos of theta plus j sine of theta. Then we have a negative, so the negative becomes times cos, becomes negative cosine of theta. And here we have a negative and we also have a what? We have a negative, so negative and a negative gives you what? A positive j sine of what? Sine of theta. Again, taking like terms together, so we have cos theta minus cos theta, that gives us what? It gives us 0. Then we have j sine theta plus j sine theta, that gives us 2j sine of what? Sine of theta. So this is our first relationship. So we have, when you add, you'll get 2 cos theta, and when you subtract our z and our 1 over z, we'll get 2j sine theta. Now let us check another relationship now from the de Moivre's theorem. We know one thing, that if you have z and you power it, so taking our z, we shall have cos of theta plus j sine of theta, then you have your power, then you have your power there. All right. Now, and we know by the laws of de Moivre's that this power will multiply the angle. All right. The power will multiply the angle, and if we had our r, then it would have powered the r. So now opening this, so we shall have cos of n theta plus j sine of what? N theta. All right, together. So that is our Zn. And what is our 1 over Zn? Our 1 over Zn. So if this one is our positive, then we are just saying the conjugate will be the change of the sign. So we shall have cos of n theta minus j of sine of what? N theta. Right? Now let us add our Zn and our 1 over Zn. So Zn plus 1 over Zn. So you can try do that. So try do that in a minute. Okay. So you shall have, you will notice that when you add the two of them, so remember this cos of n theta So we shall have it here. So cos of n theta plus j sine of n theta, this is Zn, then add this, so we shall have cos of n theta minus j sine n theta. So when you add these two, opening the bracket, again cos of n theta plus j sine of n theta, right? Then opening the bracket, you shall have cos of n theta, then negative and positive and a negative, still remains to be negative of sine n what? Sine n theta. So again, taking like terms, we have this and this, so they'll become 2 cos of n theta, right? So you have 2 cos n theta, then you have j sine theta, then j minus j sine n theta. So this and this cancels out to become 0. So you'll have this only and this added together. Again, when you subtract, we have a zn minus 1 over zn. So when you add this together, when you subtract this together, you'll get that your answer will be, so I'll just note the answer so you can try it out to expand it further. Now, but the answer by the end of the day will give us 2j sine of n what? Of n theta. All right, let me write this correctly. So we have this. So these two relationships are very, very important because these are what you're going to use in expanding functions that have cos with a power n theta and also sine with a power n of what? Power n of theta. But you can also note one thing, all right? Now this is z to any power. So what if you had our z being power 1, so what will be zn plus 1 over z? So if you put here 1, what you have? You'll have 2 cos theta, because we have 1 times theta is just theta, and this will just be this, because our z here is to power 1 and 1 over z here is also to power 1. If you take again zn when your n is 1 and n is 1 also here, if you replace 1 here, you'll see that we shall also go back to the first relationship. But now note these two relationships here, because these are the ones we're going to use to work out our sums, all right, and our expansions by the end of the day. So let's see an example on how to expand 1 over cos or sine which has a power. So find the expansion for cos cubed theta. Solution. Now these are pretty, from what you've learned before, I think we've learned something to do with binomial expansion and all that. So we shall have a bit of application of binomial expansion and expanding this. Now let's have a relationship. We know that z plus 1 over z, what will that be? Yes, that will be 2 cosine of theta. All right, that will be 2 cosine of theta. So this relationship will enable us to expand our left hand side in regards to the left hand side with regards to the right hand side. Now in our case here, your n will always be determined by the value here. So remember, we're expanding cos n theta, so our value of n here by the end of the day will be what? Will be 3. So therefore we shall cube both sides of this function. So we cube both sides of the function. So we shall have of the equation, so we shall have z 1 over z, right, cubed. So we shall just have that. This will have, remember, a cubic function. If you have a cube outside, it will cube everything inside the function. So we shall have 2 cubed. What is 2 cubed? That will be 8. Then we have cosine, then cubed what? Cubed theta. All right, now I'll interchange this, so we shall just have 8 cos cubed theta. I'll just take this on the right hand side and this one on the left and the other one on the right, so 1 over z, then raised to power 3. So that now we can expand the right hand side, then we shall give a relationship regards to the left hand side. So I want us to expand the right hand side. So we have z plus 1 over z, then raised to power 3. So we said this one will be expanded using a binomial expansion. And we know by binomial expansion, it starts with the first term having the highest power. So this power will start by the first term. Then the second will have to power 0 and anything to power 0. So remember, your powers must always be the maximum that you have here. So if I have this one is z to power 3, then that means for me to get 3, which is this 3, then my second variable will have to be to power 0. And anything to power 0 always gives you 1. All right? So we will not include 1 over z to power 0 here because it gives you what? It gives you 1. Then second, you drop the 3, reduce the power of z by 1, so it becomes 2, and then introduce your 1 over z. Now this one is the same as saying to power what? To power 1, all right? So that when you have this power 2 and this one is 1, 2 plus 1 gives you what? It gives you 3. Now remember, this one is over 0 factorial, this one is over 1 factorial, all right? And 0 factorial is 1, 1 factorial is also 1. Then again, then you have 3, drop what? Drop 2, then you have z, reduce it by power of 1, it gets what? It becomes 1, then you have 1 over z, then your z now will be squared, then all over what? All over 2 factorial. Remember, the power in the second term is always the factorial at the denominator. Then the lasts we shall have, you have 3, you have 2, you drop now 1, all right? Remember, this one is the same as saying to power 1. So drop the 1. Now in this case, our z in this place here, it will now be to power what? Power 0. And anything to power 0, we have said is what? Is 1. But what about our z? So we shall have 1 over z, 1 over z will be 1 over z, then we have cubed, then all over what? All over 3 factorial. Now simplifying further, so we shall have z cubed, so I can just say equals to plus, so we shall have 3. Now let me just expand z squared, this one is still 1 over z, then plus 3 times 2, that gives you 6, but you have 2 factorial. 2 factorial is the same as 2. So these 2 and these 2 can cancel so that you remain with 3. Now we're together. So we shall have this and this cancelling. So we shall remain with 3. Then we have z. Then opening this bracket here, we shall have 1 over z what? 1 over z squared. Alright. Now we go to the last term. 3, 2, 1. What is 3 factorial? Is the same as 3 times 2 times 1. So 3 factorial will cancel with 3 and 2 and 1 because it is the same as 3, 2, 1. So the last term will be 1 over z, then opening the power, it gives you what? It gives you cubed. So we can again simplify this further. So we shall have z cubed. We have 1z at the denominator and 1z at the numerator, so one of it can cancel with 1. So we shall have 3 what? We shall remain with a z, all right? Because 1z here will cancel with 1z. So we'll have that, then plus. Then this z here, so you have 3, which is a constant. So this z here will cancel with 1 of the z. So we shall remain with what? 1 over z. All right, together. Then the last term is 1 over z what? 1 over z cubed. Now you'll notice something, that this, the powers that appear here will always occur in pairs. All right. Now we have a z cubed and we also have a what? 1 over z cubed. We also have a z and we also have 1 over z. So we can pair them according to the powers. So we shall have z cubed plus 1 over z cubed, then plus 3 z plus 3 1 over z. In this case, we can have our z outside because it is common between this term and this term. So this is the same as saying z cubed plus 1 over z cubed plus we have our 3 outside, all right? Then we have z plus 1 over z. So we have that on the right hand side. Now when you reach here, we now go back to the relationship that we had, that zn plus 1 over zn was giving you what? 2 cos cosine of n theta. Are we together? 2 cos n theta. You can rewind a bit to check that relationship. So therefore, this part here, since we know, let me just write it down. Now, NB, we know that Zn plus 1 over Zn should give us 2 cos n theta. So we can compare these terms here with the relationship to this. So in our case here, what is our n? 3. And so in our case here, we have z cubed plus 1 over z cubed. So if you were to rewrite this part here, because I say they occur in pairs, so if I write this side here, what will I have? If I write this side, so it will be 2 cos. What is my n? My n is what? My n is 3. So I'll have 3 theta. So this part here will be 2 cosine of, now my n is 3. Sorry. So my n in this case is 3. So I'll have 3 theta. Then plus, I have 3. Then 2 cosine. What is my n in this case? My power is what? 1. So 1 times theta just give me theta. Then expanding this further, we shall have 2 cosine of 3 theta. 3 times 2 gives you 6. Then you have cosine of theta. You can simplify it further. What is common between this term and this term? You can see we have a 2 and we have a what? There's a 2 here, and a 2 is also common in this term. So we can factor out 2. So we shall remain with cos of 3 theta plus. So 2 goes here how many times? 3 times. So then cosine of what? Cosine of theta. Now remember, we are comparing the right hand side and the left hand side. So remember, all this is supposed to be equated to what? 8. So we are therefore saying, therefore cos cube theta should be the same as 2 into bracket cos cosine of 3 theta plus 3 cosine of theta. But what did we want to get? We wanted to find the expansion for cos cube theta. And you can see from what we already have here is that we already have a what? A cos cubed theta. So what do we do? For us to remain with cos cubed theta, we divide all through by what? We divide all through by 8. So dividing by 8 this side and dividing by 8 this side. So therefore we shall have cos cubed theta will be given by 1 over 4 into bracket cos of 3 theta plus 3 cos of theta. And that is the expansion for the function cos cubed theta. All right. So you can see we start by this kind of a relationship depending on the value of what? Your value of n, then expand it. So this side shall be expanded, then we shall expand this side using the binomial expansion, and we shall have our terms appear in this form. Then after this place, now you relate them according to the trigonometric ratios that we have. So we know that Zn plus 1 over Zn gives us 2 cosine of n theta. So depending on our n here, then we shall just put it here. So we shall have 2 cos, our n is 3, so 3 theta. And then we have 3, which is a constant. Then 2 cos, our n in this case is 1. So 1 times theta just gives you theta. Expanding that and comparing it to the right hand side, you get your expansion for cosine cubed theta. Now let us see a second example and see how the expansion is found. Second example, find the expansion for sine 4 theta, where 4 is the power. So solution. Now, if we have a sine function, if you noted from what we had, the relationship is where we had a sine function, we were equating it to subtraction. So therefore, z minus 1 over z, this one gives us 2j sine of theta. So when you are expanding a sine to power to a certain power n theta, then you shall equate the z being z minus 1 over z to the other side, which we have 2j sine of what? Sine of theta. Now, what is our n? Now we shall power both sides in regards to the power n. But our n in this case is what? Is 4. So we shall have z minus 1 over z, then we to power 4, then we have 2j sine of theta, then to power 4. So I can interchange this and just have 2j sine of theta to power 4, then equals to z minus 1 over z, then this one to also to power 4. Now expanding our left hand side, I've said again that this power will power everything inside the bracket. So 2 will be powered by 4. So 2 to power 4 gives you what? That should be 16. Then j also will be to power 4. Then we shall have sine of 4. Then theta gives you 1 over z. Then to power 4. Right? But we know something about j to power 4. What is j to power 4? From the powers of j, j to power 4 is 1 by the end of the day. All right? That is why it is so important to understand the powers of j. So j to power 4 will be 1. So therefore, all these will narrow down to become 16 sine to power 4, then 1 over z, then to power 4. Right? So this shall be our expansion. Now we expand the right hand side. So the right hand side using binomial expansion. So we are saying we have z minus 1 over z, then raised to power 4. So again we start with the first term as the highest power. So it will be z to power 4. Then plus we drop 4, right? I always put it into brackets so that you don't really mix up your numbers. So we drop 4, then we reduce the power of z by 1. All right. Now, what is our second term? Is it 1 over z or negative 1 over z? So our number, any number carries a sign before it. So our second term in this case is what? Negative of 1 over what? 1 over z. So therefore our second term will be negative of 1 over z to power 1, right? Because now this one is 4, then you have 3, then this one is to power what? Power, we can say power 1, but anything to power 1 is just the same number. Then we have again, now we go to the next term. So we have 4, we drop what? We drop 3, right? Then we have z squared, then negative 1 over z. Again it will be what? It will be squared, but now here we shall have what? Sorry for that. Then here we shall have 2 factorial. Are we together? Then we go to the next term. So plus. So we continue with this. So we have 4, we have 3. Then we drop what? We drop 2. Then reduce the power of z, becomes z to power 1. Then you have negative 1 over z. Then you do what? You cube. Then the power here will be your factorial at the denominator. And now we go to the last term. Your last term will be 4, 3, 2. Then you drop what? Drop 1. Then your z will be to power 0. And anything to power 0 is just 1. So now we just remain with negative 1 over z. Then to power 4. Then over what? Over 4 factorial. Now expanding now further, so we shall have equals to now z to power 4, right? Then we have 4 plus 4, we have z cubed. Then now this one is negative here, right? And you are powering it to an odd power, that is power 1. So if you're powering any number that has a negative to an odd number, the negative remains, all right? But when you power it to even number, then the negative goes, all right? Because when you multiply a negative and a negative, it gives you a positive, all right? So here, since you're powering it to power 1, it just remains to be what? 1 over z, but now the negative, since the negative remains, it will multiply with the 4. So this position here of the positive now becomes negative. So I shall just put this one as 1 over what? 1 over z. The negative, I've put it there. then plus. Now we have 4. Now we have 4 times 3, that is 12. Then 2 factorial, we can cancel a 2 here because 2 factorial is 2 with a term here. So we have what? We have 2. Then 2 times 3 gives us what? Gives us 6. Then you have z squared here. Now when you square, right, this one is an even power, so the negative goes, right, it becomes positive. So you shall remain with 1 over z. Now we shall have what? A square, because the power will power everything inside. So when the power powers the negative, it becomes positive. When the power powers 1, it becomes 1. When the power that is square powers z, it becomes z squared. Then we go to the next term. 3 factorial is the same as 3 times 2 times 1, which is 6. So 3 factorial, since this one is 6, will cancel with this, because also that one is 6. So we remain with what? Remain with 4. All right, so we shall remain with 4 here. Then we have a z. All right, now this one is an odd power, so the negative here remains. So therefore this term here changes to become what? To become a negative. Then you have 1 over z what? 1 over z cubed. Then we come to the last term. 4 times 3 times 2 times 1 is the same as 4 factorial, because 4 factorial is the same as 4 times 3 times 2 times 1. So 4 factorial cancels with everything there. Right? Yeah, you can always expand this, right? You can always expand the denominator, but you just need to know that 4 factorial is 4, 3, 2, 1. Then we have our power, we have our term here. This one is an even power, so our negative becomes a positive. So 1 over z, then the power powers the z, so we have z to power 4. Now again we can now simplify this further, so we shall just have z to power 4. Now we have a z here, so minus 4. We have 1 z and we have 3 here, so we shall have z what? Z squared. Then plus, we have 2z and z, so this and this cancels, becomes what? 6, right? Because this one is z squared, this one is z squared, so they can cancel out to become 1. So you just remain with 1 times 6, which gives you 6. Then minus 4. We have a z and we have z cubed here. So this z here cancels with 1 at the denominator, so we remain with 1 over z squared, right? Yes, they remain 2 because you have cancelled 1 here. Then plus 1 over z to power 4. Again, what do you realize? That this number occur in pairs. So we have a z to power 4, 1 over z to power 4. We have z squared, we have z squared. Then we have this one, which is just a what? Which is just a constant. So again, grouping them together, we shall have z to power 4, right? Plus 1 over z to power what? Z to power 4. So I can even put a bracket here, right? Now let's check these terms that have, okay, let me just have them here first before squared minus 4 1 over z squared. So those ones are still also the same. Then plus what? Plus a constant 6. This one now further, it is z to power 4 plus 1 over z to power 4. I said I'll group them here. Now what is common between this term and this term? It is what? Is it 4 or negative 4? Again, a number carries a sign before it. So it is negative 4. So we shall have negative 4. Then what will you remain with? Z squared. Then our position here, our sign here now will be positive, right, together. So that when you open this bracket here, this one becomes negative, and also this one here becomes what? Also becomes negative. Then plus what? Plus 6. Again, z to power n plus z1 over z to power n gives you what? It gives you 2 cos n theta. So 2 cos our n. What is our n here? Our n is 4. So 4 theta. All right. Then minus 4. Then into bracket 2 cos. What is our n again here? Our n is 2. So 2 theta. Into bracket. Then plus what? Plus 6. Then what do you have in, okay, you can open the bracket first, then you take out the common term here. Then minus 8 cos of 2 theta then plus 6. What is common of all this? It is 2 again. So you shall have 2 outside, then you have cos of 4 theta minus, we shall remain with what? 4 of cosine of 2 theta, then plus what? Plus 3. All right. Now we compare the right hand side and the left hand side. So we had this term here on the left hand side. So hence, just say hence 16 sine 4 theta equals to 2 cos of 4 theta minus 4 cos of 2 theta plus what? Plus 3. Then divide all sides, because we want the sine 4 theta, sine of power 4 theta. So we divide all through by what? By 16. So therefore we shall remain with sine 4 theta, that is the power, will be 1 over 8, because we will divide all through by 16. Then we shall have into bracket cos of 4 theta minus 4 cos of 2 theta, then plus 3. And therefore that gives you the expansion for the sine to power 4 theta. And that is it on how you expand the cosine of n theta n, the sine of n theta function. So kindly, as said again, remember to subscribe, share, and also comment how these lessons are being helpful to you. And if you're doing your neck paper, this question here can give you around 8 marks to 10 marks. All right, so follow through. Where you don't understand, you can kindly ask a question, and we will clarify further. So in the next lesson, we shall be checking on more application of complex numbers, and that basically is in solving complex equations. So we shall check a few examples from the next past papers, and I hope you will really enjoy learning. So thank you and keep locked.